Trying to keep up with AI development these days, it really feels like trying to drink from a fire hose.
It absolutely does. Every single day, there's something, models, papers, discussions popping up everywhere.
So think of this as, well, your curated digest.
Mhm.
We sifted through the AI Daily News Digest from May 13th, 2025.
Yep, pulled out what we thought were the most interesting highlights.
Exactly. The key developments, maybe some surprising facts, looking at new models, new research directions, what people are actually talking about.
The idea is to give you the core insights, without getting totally lost in the weeds.
A shortcut to feeling, well, reasonably informed for the day.
Precisely. And looking at just one day like this can actually show some broader trends and really fascinating experiments going on.
Okay, let's dive right in then. First up, there's been some chatter about a new model, Intellect 2, from Prime Intellect.
Right, that's a 32 billion parameter model. But what's really catching attention isn't just the size, it's how they trained it.
How so?
Well, they used globally distributed reinforcement learning. So they took their QWQ32B base model, which is sort of an efficient version of a previous one, and used their own framework, PrimeRL, to coordinate the training across, well, potentially many different systems worldwide.
So moving away from the massive centralized training cluster idea.
Exactly. It's a step towards decentralization. They also had ways to verify the reward signals, especially for math and coding tasks.
Making sure it's learning correctly.
Right. And they made some architectural changes, too, for stability and handling longer context lengths, like up to 10,000 tokens, which is quite a jump.
Did it perform better?
The benchmarks were a bit mixed, actually. It slightly outperformed the older QWQ32B on some math and coding tests like AME24 and Live Code Bench,
Okay.
but it actually did a little worse on another one, IFEVL.
So not a huge leap in performance then.
Maybe not on the specific tests, but the really significant thing here, the bigger picture, is that decentralized RL training approach.
Yeah, that seems like the main story.
It really is. People are already talking about how this could link up with blockchain or P2P concepts for managing compute power, maybe even for inference later on, not just training.
That opens up a whole lot of questions about access, security, democratizing AI maybe.
Definitely. It's a fundamental shift in thinking about how we build these things.
Okay, sticking with new approaches, Microsoft announced something called the Artist Framework.
Yes, artist. And this isn't a model itself, it's more like a methodology, a way to build models that reason better.
A recipe for smarter AI.
Kind of. It brings together three key ideas.
Mm-hmm.
Making the AI act more like an agent, integrating external tools effectively, and using reinforcement learning to get better.
And they use a specific technique, GRPO.
Right. GRPO, Group Relative Policy Optimization. It's basically a specialized way they're fine-tuning the model using RL.
So what does that actually let the AI do differently?
Well, one clever part is how they focus the learning. They use something called loss masking during the RL phase, which means the learning really zeroes in on the reasoning steps and the actions the model takes, not just, say, whether the final answer was right if it just copied something.
Rewarding the process, not just the outcome.
Exactly. And the reward system itself is more complex. It looks at the answer, sure, but also the format, how well it used tools, the state of those tools.
And does it work? Did they see improvements?
They reported some pretty significant gains, up to 22% absolute improvement on math reasoning benchmarks like AMC and AIM.
Wow, that's substantial.
And even more striking, on a benchmark called a bench, which tests multi-turn function calling, basically, using tools over several steps, they saw more than double the accuracy compared to their baseline.
Double. What's driving that kind of improvement?
They attribute it to the AI developing what they call emergent agentic behaviors, things like self-refinement, self-correction, even self-reflection during problem solving.
So the AI is learning to think about its own thinking process, in a way.
That seems to be the idea. Though there's a bit of discussion, about how much of this performance, especially compared to something like GPT-4o, is down to the specific nature of the benchmarks.
Right, especially benchmarks that heavily involve tool use.
Precisely. Is it a general reasoning leap, or is it getting really good at these specific tool-heavy tasks? It's an important nuance.
It really highlights the challenge of evaluation, doesn't it?
Right.
Okay, moving to something quite different. Sakana AI and their continuous thought machine, or CTM.
Yeah, this one's definitely thinking outside the usual box. It's a novel architecture inspired more by biological systems.
Wow, so what's the core idea?
Instead of just focusing on whether a neuron fires or not, CTM emphasizes the timing and synchronization of neuron activity, right down to the individual neuron level as the driver for reasoning.
Timing. So when a neuron fires, matters as much as if it fires.
Essentially, yes.
Huh.
The neurons in a CTM actually encode signal history and timing information using parameters they can learn.
Okay, that sounds complex. What's the benefit?
The hope is that this allows for more complex, temporally coordinated behaviors. Think processes unfolding over time. And potentially, it might even make the AI's reasoning more interpretable because you could trace the timing patterns.
And are they seeing results?
Sakana AI reports gains in efficiency and problem-solving ability across different tasks.
Interesting. What's the buzz in the community about this? Is everyone jumping on board?
There's definitely acknowledgement that it's innovative, a fresh approach, but there's also some caution.
Like,
Well, people want to see more direct comparisons on standard benchmarks against established models and a clearer picture of the real-world practical impact. Is it just cool science, or does it solve problems significantly better?
fair enough. Need to see the proof in the pudding, so to speak.
Yeah.
Okay, let's shift gears again. OpenAI has launched Health Bench.
Right, a new evaluation benchmark specifically for AI in healthcare.
And the notable thing here is the development process.
Yes, they apparently got input from over 250 physicians worldwide to build it.
Wow, that's extensive collaboration.
Yeah.
So the goal is?
To get a more accurate, more clinically relevant assessment of how these models perform in actual health scenarios, not just general knowledge tests.
Moving beyond textbook questions to real-world applicability.
Exactly. And they've made it available on OpenAI's GitHub, which is good for transparency and broader use.
This seems like a really positive development for a critical field.
Yeah.
Okay, quick hit. ByteDance released something called Dreamo.
Yep, Dreamo. They put it up on Hugging Face. It's described as a unified framework for image customization.
Unified how?
It apparently handles several different tasks like specific ID generation, intellectual property integration, virtual try-ons, style transfer, all within one model.
And meant to be lightweight.
Lightweight and performant, yeah. So
Yeah.
potentially quite versatile for creative applications.
Interesting. Okay, finally, let's touch on a more conceptual idea from Andrej Karpathy. He's talking about system prompt learning.
Yeah, this is less about a specific release and more about a potential future direction for LLM training. Karpathy's basically suggesting we might be overlooking a major learning paradigm beyond just gradient descent.
Okay, so what's the alternative he's proposing?
He draws a parallel to reinforcement learning in that it involves trial and error. But here's the twist.
Oh.
Instead of the learning algorithm adjusting the model's internal weights via gradient descent, it would actually learn by making edits to the system prompt itself.
Wait, the AI learns by rewriting its own instructions.
That's the core idea. You know, those initial instructions you give an LLM. Karpathy envisions a future where a large part of that prompt isn't written by humans, but is actually learned by the AI through this trial and error process.
So it's like the AI is learning how to learn or how to approach problems by refining its own high-level guidance.
Precisely. He uses this analogy of the LLM essentially writing a book for itself on how to solve problems. It's a fascinating idea about a different layer of learning.
That really does bend your mind a bit, thinking about AI learning its own operating manual. Okay, wow, that was quite a tour.
It really was. From decentralized training with Intellect 2 to advanced reasoning with Artist.
Sakana's bio-inspired CTMs, OpenAI's specialized health bench, ByteDance's Dreamo for images.
And wrapping up with Karpathy's look towards maybe system prompt learning. It's a snapshot, but it shows the sheer breadth of what's happening.
Infrastructure, reasoning methods, specific applications, even fundamental learning concepts.
Yeah, it covers a lot of ground.
So here's a thought to leave you with. Considering all these different threads, the push for decentralization, the quest for better reasoning, these novel architectures, the focus on evaluation, what do you think will actually be the most impactful shift we see in AI over, say, the next year or so?
That's the million-dollar question, isn't it? Will it be the underlying training methods, how we measure true capability, or some completely unexpected architectural breakthrough?
It's definitely not slowing down. We hope this gives you a bit more insight into some of the currents shaping the field right now. Keep exploring, keep thinking about the implications.